My name's Leo and I'm a boat builder and a sailor, and I'm on a mission to rebuild and restore this 108-year-old classic sailing yacht, Tally-Ho. Okay, so last week I was talking about the shape of the boat and the way that it's different from its lines drawing. The port side is very, very different because she was run aground on a reef in the 60s and that side was rebuilt to a different shape. The starboard side is much more similar in principle, but it is still different from the lines in several ways. The way that is most significant is on the top sides of the boat above the waterline. She's very flat where she should have some shape, but also all the way down her length she is slightly different from her lines in that the turn of the bilge is in a slightly different place and so on. Now, knowing what I know about Stowe & Son, the original builder of Tally-Ho, I can only assume that the flatness in the top side planks on the starboard side is something that was induced into the boat after she was built. Now that could be down to collision on the starboard side, being squashed against a harbour wall. It could be down to the load on the chain plates pulling up in the rig. That can pull the frames much straighter, that's definitely a possibility.
Hello.
This is Celia.
Hello.
Ce's come to visit for about a week. How many years have we known each other?
12? No.
More
How old
than
are
that.
we? 13 years.
13 years. I basically lofted out the curve of this section of the boat from the lines drawing, and now I'm comparing it to the actual shape of the boat. Again, there's quite a big difference in the shape of the boat. I've been really scratching my head trying to figure out the best way to proceed with this. I know that the boat isn't fair. Fairness just means basically smoothness of the lines. It means that every line you can take from the outside of the boat is a long, sweeping, smooth curve with no bumps in it or flat spots. So I know the boat isn't fair and I know I have to remedy that. I've been trying to figure out ways I can do it without having a huge amount more work, but basically I keep on coming back to the fact that anything I do is going to be a compromise. The only way really to get the boat as Albert Strange designed her is to completely loft her out, and that means enlarging the plans to full size and then using those plans as templates for each of the frames. Now the reason it's such a hard decision is not so much about the extra work, it's more about the principle of what I'm doing. When boats were built back in the turn of the century, they were often not built exactly to their lines. The finished boat was more often than not a combination of the designer's idea and the builder's techniques and the builder's idea. So in some ways I would like to restore the boat that was built rather than the boat that was designed. However, in this case the boat is so old and has had such rough treatment that it's so hard to tell how she was built and how much of this change has come about through the hardships that she's been through and how much was built into her. I think if I try and make some changes in some areas, I could improve the boat from how she is now, but it would be a messy solution. There'd be a high risk of not getting it quite right, and at the end she wouldn't be the boat that Albert Strange designed. So I think the only way to really do this boat justice and to have a finished product that is elegant and fitting to the well thought of designer that drew the boat is to actually loft the boat out full size. That's a bit of extra work, but I think it'll be worth it, and I've never lofted a boat as big as this, so it'll be an interesting learning experience for me. So the first thing to do is to clear the workshop and make a lofting floor.
La carretera, con la carretera, con la carretera, para mi amor, con la carretera.
I get a good wibble.
En la noche, por la carretera, para mi amor, un otro meneo. no mentira, bruta la verdad. We'll get by under the starry sky.
You're so close to my face right now. Let's do a pirate impression. We need an eye patch for this.
Por la carretera esconde el coyote, perdido el destino en la oscuridad.
Alright, so we've got one coat of paint on our ply already. Normally when you build a lofting floor, you'd probably be building it on a frame, or at least laying down bits of 2x4 or something underneath to screw it to. Because we got such a perfectly flat concrete floor here, I decided not to bother with that. But what I'm finding is that where the boards are slightly warped, they need to be stuck down. So we're going to stick them down with some strong mounting tape. You've got to try and get the smoothest surface as possible so it's easy to draw on and lay your battens out on without having any bumps at all. So ideally you'd use good quality ply. We've used the worst quality ply you can get pretty much because it was cheaper. We've used filler to smooth out the worst of the knots. I had to go around the posts here which hold up my mezzanine, but the bottom of the posts aren't actually fastened into the floor at all, so I've cut a slot around them. They can actually be shifted a few inches either side if we have to draw a line right through them.
We get high, up on the starry sky, broke down on the shoulder of the soul.
Here's a technique we developed to get double-sided tape underneath the plywood if we stuck it down and there's a bit which isn't stuck down properly. Tape the backing tape onto the back of this bit of pattern ply. It's like magic. Uh-oh. Alright, so to loft a boat full size, you need several very long battens, at least as long as the boat. It's going to be hard for me to find any pieces 50 foot long around here, so I've got some pieces that are 20 foot long, and I'm going to scarf them together. So I've made a scarfing jig. It's just a gentle slope basically on these pieces on the side. I'm going to use this to make lots of scarves identical. Hopefully I'll be able to glue these pieces together and make some really long battens. You're always going to get the same ratio, which is about 30:1. You can adjust the length of the scarf by adjusting the depth of the butts at the end of the scarf. I put a couple of screws in the bottom just to hold this end down, and I've got a wedge at the back to hold that end down. And then I can adjust the depth of my router to adjust the depth of the butt at the end of the scarf. And then when I get to the other end, I just have to watch out that I go to the right distance so that the butt on the other end is the same depth. Once I've done that once for any size of stock, then I can mark that distance, and then all the other ones I just go to the same mark and it should be exactly the same. If they're 1/2 mil oversized, it's really easy to just take a tiny bit off with a block plane. Now, for a long time I found it very frustrating that if I wear a dust mask and safety goggles at the same time, the goggles steam up. Now, I think I might have found a solution to that. These dust masks, specifically the ones with the exhaust vent on the front, and I'm using goggles which are supposed to be anti-fogging, and the point is that air you breathe out comes out this exhaust rather than around your nose. I've just been using these for quite a while. I didn't get any fog at all. So when I'm done routing the scarves, I just clean up the butts with a chisel. If they're slightly proud at all, then all you do is turn this one over. You feel very easily here that it's just probably 1/2 mil or less proud. With this one upside down, I'll just plane the back of the scarf until it's flush. Right, so I've got a selection of battens, cut and scarfed. Basically you have to have several different sizes of battens for the different lines depending on how curved they are. So the thicker batten is for the shear line and the gentle curves, and then thinner battens are for the curves with more sweep in them. And then you've got some short battens here which are for the body plan, for marking out the curves of the frames and so on. So we tried using the laser level to get straight lines, but just found it was too much of a hassle. Just gone to the old-fashioned taut line between these 2 points, mark down it, and then follow that with a straight edge. Okay, so now we've drawn our baseline, which is the long line going along the bottom of the boat, basically. We're now drawing the perpendiculars, which are the stations. We've marked them off on the baseline every 2 feet. And now we're using Pythagoras to square off the perpendicular stations. Bring your forks down. Right, well we've nearly finished our first grid, so putting on the water lines and the perpendiculars. And in terms of guidance for doing this, I've been referring to this book, Boat Building, by Howard Chappell, which is well known as one of the Bibles really of traditional boat building. This was written in 1941, I believe, but it's very relevant for this sort of work. This is one thing I've learned from people who have done a lot of lofting, is that you shouldn't be afraid of rubbing things out and trying to improve them, because it's pretty much unavoidable, it will happen, and it's better to do it right and get it accurate. Okay, well I finally got a lofting floor that's ready to start lofting on, and already even just getting up to this stage I've learnt quite a lot. You should really get the best quality ply you can afford, which I didn't do, but timber and particularly ply prices are just ridiculously high at the moment. Even this stuff, which is really terrible quality, was over 25 bucks a sheet, I think. I'd also think very carefully about how I'm going to keep it flat and stable. The double-sided tape didn't work as well as I thought it would. To solve that problem, I used a skill saw to make cuts in the ply, cut them in the middle, and then they flattened out pretty well, so I've just had to do a few more cuts. After that, we had to fill those cuts again and paint over the filler, and I actually ended up painting over pretty much everywhere in between the lines that we'd drawn for the grid. Because the other thing I've learned is how quickly a white surface like this gets dirty. So I've now bought these white socks and these socks stay on only on the lofting floor. Okay, so this is called the body plan, and this is a 4.5 view of the boat. This side of this particular part of the drawing is the bow sections of the boat, 1 through 13, and this side are the stern sections. So you can see the shape of the boat at the front coming out to form a wineglass shape in the middle, and that wineglass shape is getting smaller towards the back or the stern of the boat, right up to the transom, which is this flat part on the back of the boat. Each of these stations shows the shape of a frame, which is like a rib on the rib cage inside the boat. There's also a frame in between each of these stations, so there's 22 stations here, but there's 44 frames in the boat. Now this is called the profile plan or profile view, and pretty self-explanatory. It shows the boat viewed from the side. This plan is called the half breadth plan, and it shows the boat from the top or bottom, again pretty obvious. Now what's interesting is how these lines all relate to each other. So these lines, which are these stations, are the same as these vertical lines here, which are called perpendiculars on the lofting floor. So number 17, for instance, which is this one here, is number 17 here on the profile, and number 17 here on the half breadth. Water lines are these horizontal lines. Now the water lines on the body plan are in the same place, they go straight through and are the same, but on the half breadth plan, looking from above or below, you can see the water lines here are curved lines. So you have water line 1 is this line. So that is the shape of the boat as if you chopped it in half on the water line and then looked at it from above, you'd see this shape. And then you have the buttock lines. Now the buttock lines are straight on the half breadth plan. On the body plan, they're vertical, and on the profile view, these are curved lines. So if you cut the boat vertically, a couple of feet in from the outside on one side, and then looked at it from the side, you would see this shape of this curve. Now it gets more complicated still, because then you have diagonals. Diagonals are these lines. These lines aren't shown on the profile view, but they're shown on the other side of the half breadth plan. So if you slice the boat on any of these lines, these are the shapes that you'd get. And these are actually particularly useful for this type of boat because they are perpendicular to the outside surface of the boat in most places, which gives you a more accurate measurement. It also represents more the curves of how you'll be planking the boat. So the more gentle and fair these curves are, the easier the boat will be to plank later on. Now here we have a table of offsets as drawn by Albert Strange in 1909. He's given us the half breadths on deck and the half breadths on the bottom of the keel, and all the other measurements are the distances out from the centre line to the stations on each water line on the body plan. And in fact, it's good to expect to find errors in the table of offsets. Because it's a tedious job, there may be clerical errors, and there will certainly be discrepancies in accuracy where we're going to have to adjust these measurements to make a fair curve. First thing to do, now that I've got all my water lines and perpendiculars laid out and accurate, is to lay out the profile view. And the first part of that is going to be to set down the shear line of the boat. So this is the stiffest, widest batten I've got, and I've just laid it down on the shear curve. This is the shape that the batten makes for the shear line when I put it to all the marks that I got off the table of offsets. You can see from there, this line isn't fair. There's a big kink in it around here, but that's not a problem. This is part of the lofting and fairing process, so all I'm going to do is take out nails and add in other nails and adjust this until it's a nice fair curve, and that's something that can only really be judged by eye in this sort of situation. The other thing which is really important is that the batten is supported beyond the end of the curve. If the last support is at the end of the boat, it will curve unevenly, so that's why I've got these weights beyond the end of the boat, and that's why the batten is longer than it needs to be. I've now got my first line of the boat down on the lofting floor, which feels great, and the next step is to lay down the profile of the keel and stem. Depth below waterline to bottom of keel. Section 1, 1 foot 2.5 inches. Here's the waterline. This is the perpendicular for section 1. I'm going to measure very carefully from here and I'm just banging a nail in right there. Section 2. Now it's 9:15 and I really should have some supper, but I can just tell that this process is just starting to get to the really fun bit. I've literally had these socks for about 6 hours. Now I want to draw in the stem here as it comes up to meet the shear, but the only measurements I have for the stem are measured down from the waterline. So as that stem becomes more vertical, then those measurements aren't very accurate. So I'm going to take my own measurements off the lines drawings, take my own offsets horizontally out from the first station to the stem, and I'm going to use them to be able to draw the stem more accurately. Okay, so now we've laid down the shear line, the line of the top of the hull, and we've laid down the stem, 4-foot keel. Now I want to draw on the line of the stern post. There's no measurements for that in the table of offsets, so I have to measure my own offsets. So it's very simple. I'm just going to use my scale rule, 3/4 scale, and I'm going to measure the distances aft of station 21 on each waterline. Alright, well I'd like to ask a favour from you guys. Recently I got all this timber trucked up here from southern Georgia. Unfortunately it didn't all fit on the flatbed, and there's still 2 bundles of this live oak down there in southern Georgia waiting to come up here to Washington. Partial load on the flatbed for the 2 stacks will cost me over $3,000. So I wanted to ask if there's anyone who might be driving from southern Georgia up to Washington who might be able to give me a better price on it. Now they are big and heavy. I imagine both stacks together weigh between 5,500 and 7,500 pounds, and the longer one is about 14 foot long. I know there are websites for getting quotes on things like this, but I don't think commercially I'll get anywhere below $3,000. So this is just a long shot to see if there might be anyone coming up from that way anyway who might give me a good rate. So if you know anyone, please let me know. Thanks. Alright guys, well that's it for now, so thanks a lot for watching, and a massive thank you to everyone who's donated or otherwise supported the Tally-Ho project. You know who you are, and your support makes a really huge difference. It also means I'm able to take the time to make and edit these videos, so thanks again. And I'll see you all next time, when hopefully I'm going to be finishing the lofting process and moving on to the next job. Alright, cheers. Mentira, la verdad.